Saxon's Trig, lesson 73, is about regular polygons. Now, polygons, we know, are straight-sided shapes that close. If we have 3 sides, it's a triangle. 4 sides is a quadrilateral. 5 sides is the pentagon, and so on. When it says regular, regular is indicating that all the sides are the same length. So for this triangle, that's going to mean it's equilateral and also equiangular. If all 4 sides of a quadrilateral are the same, that means I'm dealing with a square. And then there's no special names for your 5-sided and so forth. And it basically says when we have them that are regular and we inscribe it inside a circle, or a circle is outside of that shape, that's what we're going to be dealing with here. So in example 1, find the area and the perimeter of a regular pentagon. Yeah, those are slightly slanted. That should have been slightly more slanted. Okay, and then here's my circle. Okay, find the area and the perimeter of a regular pentagon. It reminds you 5-sided that is inscribed in a circle, and the circle's radius is 6. So from the center of the circle out, that's a 6. But to find the perimeter or the area, more the area, I need triangular shapes. So if I draw a triangle here and I work on the area of this triangle, how many identical triangles will I have going around? 5 times the area for the triangle. And the area for the triangle formula is half base times height. So that will give me the area of the whole thing. Now, in order to get the base, I don't know the base and I don't know the height. Drawing the height in here. Okay. However, I do know that a circle is worth 360 degrees. So this core here in the center should be 360 degrees. How many basic angles have I split in here if I've drawn in the 5 triangles? 1, 2, 3, 4, well, obviously 5. So that will always match the amount of sides. So if I take 360 and I divide it into 5 triangles, I am getting 735. So 72 degrees is how much is inside each of those core angles. Now I drew a height in, which in essence took that 72 and halved it into 36. So in this triangle, I was trying to see which one had more space to try to write the 36. Now I have a right triangle here from having drawn in my height. I have found a degree because it was based on a circle split up into its amount of parts. And now I can do sine, cosine, or tangent to solve for the things that I need. So the adjacent to the 36 is the height that I want. So if I do cosine of 36 degrees, I get ca adjacent, which is the height I want, over its hypotenuse. Now the hypotenuse is, it's a radius. So this 6 is everywhere I need it to be, no matter where. So this is a 6. So the height is found by doing cosine of 36 times 6. So my height will be, looking, 6 times this, no, that's sine. Here it is, 4.8. I want to double check that. Cosine 36. Yep, 4.85. Okay, 4.8. They took it to a different, they had 3 decimal places, doesn't matter. And then to find the base part, that is opposite the 36. So that's going to be sine of 36 equals the opposite, which is the base, over the hypotenuse, which is still 6. So sine of 36 times 6 will give me the base 3.52. Now I got to be a little careful here because this was not the full base of the triangle. It was just that little piece. So the base of the large triangle, which I'm trying to find the area for to use up here, is doubling the base, because if it's here, it's the same on this side. So it's 3.52 times 2, doubling that to, should be like 10 point something. When I'm looking at theirs, it looks like they rounded it off to 10. I would not. Okay, so I would be filling this in here, 5 times a half times the base, which would be 10.04. That's why they rounded it off to 10, but again, I would be precise. And my height, 4.85. Then doing all of that on the calculator should get you fairly close to 85.6. Now, with my not rounding it off to 10, it's probably a little bit different, but I'm pulling their number. And then its area, but they didn't tell me any dimensions with this. So at this point, they label it units squared. You should put something with it, and since we don't know a measurement, units is the best way to deal with that. We were also asked to find the perimeter. Now that we know that the bottom, the base, is basically 10.04, and then how many of those do we have? 5 of them. So, why did they suddenly shift that to 7 Did I miss multiply? 2 times 2 is 4. 10. Oh my goodness gracious. Yes, I did. Hopefully you guys caught that. That should have been 7.04. Yeah, okay. So this is definitely going to be a little bit off if you had done my numbers. Now let's do perimeter. 7.045 times, because there are 5 sides, to give us the perimeter, which should be fairly close to, not totally accurate, 35.27. And again, I need a word with it, so we use units. Example 2. The perimeter of a regular polygon of 8 sides is 48. So the perimeter is 48 units. They didn't say it, but it's kind of implied. Find the area for the polygon. Okay, so it's a lot harder for me to draw an 8-sided shape. So I'm just going to draw the triangle that's going to be connecting to the center, basically, and know that you've got 8 of them going around here. All right, so I know I'm going to have to draw my height in. I know that the perimeter all the way around was 48. If I divide that by the 8 sides, that'll tell me how long the base part is, which would be what did they? Oh, yes, 6, duh. Okay. Yeah, so the whole side is 6. But in the part here where I just want to use this side of the triangle, I'm going to half that and say that this side is worth 3, this side is worth 3. Here's my right angle. And I need to stop and find the degree in here. So 360 is the circle that it's encased in. We've split it into 8 equal triangles, which is going to be, I was hoping it gave me that without my having to stop and figure it out. Oh, yes, 45, Double check that. Yes, okay, so now that's for the whole angle, but when I drew the height in, I halved it. So this goes to 22.5 degrees. And ultimately, since it wants the area, we know that it's half the base times the height, and the base we know is 6, which is the full length, and now we need to find the height. So the height is adjacent to this, so cosine of 22.5 degrees equals the height over the hypotenuse. Oh, I don't know the hypotenuse. So I don't want to do cosine. Let's switch it to tangent. TOA, opposite, okay, change that, opposite to 3 over adjacent, which is height. Now that I can find. So tangent of 22.5 turns it into a decimal. So point something or other times the h when you move it over equals 3. 3 divided by this decimal will tell me the height. And that should end up being, I was double checking. Here's where they did the tangent. 3 divided by, 7.24. Okay, just want to make sure I wasn't getting wrong numbers anywhere again. So the height is 7.24, and I filled that in over here where I was doing the area of a triangle is half base times height, but I failed to put in front how many triangles did I have. I actually had 8 sides, therefore I have 8 triangles. So ultimately you're doing 4 times 6 is 24 times 7.24, and they're saying that should come out to be 173.76 units because they didn't give me a word, and squared, or a measurement. I want to estimate that just a tad. 424 times 7. Yeah, that feels like it is in the ballpark.